This is more of homework set 19, still on multiplication and divisions of rational expressions. I'm going to start number 6 by rewriting x squared minus 4 over 4x plus 4 times x plus 1 over, there's another x squared minus 4. Now, first up, I'm going to cancel this one with this one. Now remember, I'm really just dividing by 1. And in this denominator here, down here, I can take a 4 out. So if I remove a 4, what's left is x plus 1. And then I see this x plus 1 will cancel with that x plus 1. So what's left? What's left on the top? Well, on the top is just a 1 times a 1. So there's a 1 left on the top. On the bottom, what do we have on the bottom? I got a 4. That canceled. That canceled. So all that's left on the bottom is a 4. That's it. That's number 6. Now I'm going to make this complete by saying what x cannot equal. All of this works as long as x is not equal. Go back to the original factored form. Look at the denominators. What can you not have for 0? That's going to give you 0. Negative 1, 2, and negative 2. So negative 1 plus or minus 2. Question 7. Oh, we have a division. So the first thing I'm going to do is rewrite, but I'm going to flip this over, right? Change division to multiplication by the reciprocal. So let's rewrite it. Matter of fact, as I rewrite it, why don't I go ahead and factor A, 5, 1's plus, 1's minus, times, now I'm changing this division to a multiplication of the reciprocal, just turn it over, a plus 5 squared over 1. And now what I've got is some cancellation, right? That a plus 5 on the bottom left will cancel one of these on the top right. So this one down here will cancel with one of those two up here. Now what's left? On the top is this a plus 5 times 1. So it's just an a plus 5 on the top. So on the top is an a plus 5. And on the bottom, what do we have on the bottom here? I got a 1 times a 1 times an a minus 5. So just an a minus 5 in that denominator. Now, just to be complete, I'm going to say this is going to work as long as a is not equal to, go back to the originals and see what's going to make the denominator 0. 5 and negative 5. But now one time this was a denominator, right? So what's going to make that 0? Negative 5. But I've already accounted for the negative 5 over here. So I'm just going to say a cannot equal plus or minus 5. Question 8 looks kind of big, but let's just start factoring everything that we can. So top left, nothing factors here. What can we do here? Oh, 20, 35, and 15. You see a 5 common? There's two y's, y and no y. So I can at least take out a 5. So let's do that. So we'll get 4y minus 3 over 5. Now what's left? 20 divided by 5 is 4y squared minus 35 divided by 5, 7y. 15 divided by 5 is 3 times, okay, now what can we do over here? This top right. I got 5's in common. Let's take the 5 out. Then it's going to cancel with that one on the bottom left, right? So we'll get 3y squared minus, now there was a 5, but we removed it, so it's just a y, and negative 10 divided by that 5 is a minus 2 over, bottom right, 3y plus 2, nothing to factor there. Now, let's take a look at this one over here. Let's try to factor this right here. All right, so I'm going to rewrite everything. 4y minus 3 over 5. Now, let's see what we can do. All right, so first up, I got a 4. Do I want to use a 4 and a 1 or a 2 and a 2? I like to go with the pair that's closest together. So I'm going to start out with a 2 and a 2. Maybe it'll work, maybe it won't. So 2y. Now, if I do that, there's only one way to get a 3. Where am I? Right there. Only one way to get a 3. 3 and a 1. Now, both of them are 2, so it doesn't matter where I put the 3. A 3 and a 1. Does this have a chance of working? Look at the outer product and the inner product. 2y, 6y. Oh, okay. Well, a 2 and a 6. 2 and a 6, I can't get, what am I looking for? A 7. I can't get a 7 out of that. All right, so this one is not going to work. Had to give it a try, though. Let's try it again. So 4y minus 3 over, there's the 5. Okay, the 2 and the 2 didn't work, so let's try a 4y and a y. Now, what do we have? I need to get, okay, what do I put here and here? Okay, here's where we are. 3 and a 1. Only one way to get it, a 3 and a 1. So where am I going to put the 3? Where am I going to put the 1? All right, well, let's see. What if I put the 3 over here and the 1 here? That would give me a 12 and a 1, too big. If I put the 3 here and a 1 here, oh, a 3 and a 4, I can get a 7 out of that. So that's the way to go. So I'm going to put the 3 here, the 1 here. Now, back up. What about signs? 3 is positive. So they both have the same sign. It's going to be that middle minus sign. So 4y minus 3, y minus 1. Times. Okay, let's see what we get here. 5. Break this apart. Okay, 3y squared. Well, we're lucky here. That's prime, and a 2 is prime. So not too much problem here. So we'll get 3y and y. Now, what do we use for the 2? A 2 and a 1. So where do I put the 2? Where do I put the 1? Well, if I put the 2 here, I get 6 and 1. 6 and 1. I'm just looking for a 1. So what if I put the 2 here and the 1 here? I get a 2 and a 3. I can get a 1 out of that. So let's put the 2 here, the 1 here. Now, the 2 is negative. So these two numbers have opposite signs. That middle sign, that minus sign, is going to go with the bigger product. Here's what I mean. What's the inner product? 2y. What's the outer product? 3y. The outer product's bigger. So I want this to be negative. So I will put that minus sign here, right? That way I'll get minus 3y, and then plus 2y is minus y. Okay, oh, well, how about this? 3y plus 2. I probably could have used that as a guide, because I see, okay, what do I put here? I kind of know how things are written. Oh, I could have done that over here. What do I put here? Well, I kind of see it up here, so I might have tried that as a guide. All right, so what's going to cancel? 4y minus 3, 4y minus 3, top left, bottom left. Now, oh, what about over here, these 5s? That 5 on the bottom left will cancel with that 5 on the top right. Then this 3y plus 2 will cancel with that 3y plus 2. Y minus 1 will cancel with y minus 1. Everything canceled. But when everything cancels, remember, when you cancel something, you're left with a 1. 1, 1, 1, 1, 1, 1, 1, 1. So now what I've got is 1 times 1 times 1 times 1 times 1. Everything's 1 over 1. So I just get 1 over 1, but 1 over 1 is just equal to 1. That's it. So what we're saying here is that this set of computing instructions, you put in a number for y and you do all this computation, what do you get back out? You get back out a 1. So it says all the y's canceled out. So this is independent of y. It doesn't matter what y you put in, you're going to get a 1. Pick any number for y at all, put it in here. I pick 1, you pick 1, we compute. What do we both get? We both get 1. And that finishes up questions 6, 7, and 8 here on homework set 19.